Hi everyone, welcome back to ETN Chen channel. Today I want to explain something in chemistry known as fuel cell, and that is a very innovative part of green energy that we're talking about in our world today. So you might be wondering, why are we talking about fuel cells? Well, the truth is, with climate change and global warming, humanity is pressed to find a new solution to the energy crisis that we're facing at the moment. And one of those viable alternatives is something known as a fuel cell. You might be wondering, hang on, what is a fuel cell? Well, a fuel cell is a battery that can convert combustible gases directly into electricity without going through the combustion phase, which increases the efficiency by a large amount. So, let me give you an example of what a fuel cell looks like. So imagine you have a battery like this, a fuel cell battery. Then you have something like a membrane. It's actually called the PEM, which is called the proton um, something membrane. Proton exclusion membrane. Actually, I forgot about the exact. Oh yeah, proton exchange membrane. Yeah. So P stands for proton, E stands for exchange, M stands for membrane. So essentially what happens there is it is semi permeable membrane, meaning that protons can pass this membrane and other particles can't. So essentially what happens in a fuel cell is, suppose you have hydrogen gas feeding into the left chamber. We call it the anode, and let's say this whole structure is imagine you have a box, right? A metal box, let's say. You have two chambers separated by a thin membrane, and on top of the two chambers you have an electrical wire that connects them together, and it connects through, let's say, a load. We'll call this symbol resistor, but in fact that's a load, right? And what happens here is, when hydrogen gas is poured inside, we want to ionize them. And what I mean by ionizing them is extracting an electron from the outer shell of a hydrogen atom. So the half equation in this side of the cell is, so you have a hydrogen gas, you want to ideally heat it up so hot that the proton and the electron effectively separates. So the hydrogen gas is turned into a hydrogen ion gaseous phase, of course, plus an electron, and obviously you have two hydrogen ions and two electrons, because why? Well, hydrogen gas is already H2, so you have two hydrogen atoms bonded together by a covalent bond, and a covalent bond is basically sharing of electrons, which is equivalent to this. So, and we know that hydrogen has only one proton, so effectively the scenario is like this, where the two positively charged particles are protons, and the two minute particles are known as electrons. So essentially it's that thing that is known as hydrogen gas. So once you analyze them, what you get is um, positively charged H plus ions, or known as protons. So those are protons, and then you have electrons. So you have a separation of those two. And what happens here is the electrons would travel through the copper wires, through the load, and back down again. Whereas the protons would travel past the proton exclusion membrane, a semi-permeable membrane, and join to the other side. And on the other side, what you have is a constant supply of oxygen gas. And what happens here is the protons and the electrons and oxygen atoms combine together, bam, and then you get what? Then you get H2O, water. What happens here is, well, the proton, which is H plus an electron and plus oxygen gas gets H2O, which is water. And we can balance this equation out pretty easily. So put a 2 there on the right hand side and put a 4 on the left hand side and put a 4 on the electron. Actually, no, it wouldn't be 4 because there's a redox reaction. But anyways, oh wait, yeah, you would need a 4, sorry. Yeah, 4. So 4 protons plus 4 electrons plus 1 oxygen atom gets you 2 water molecules. So effectively, what happens here is when the protons pass through the membrane and the electron pass through the wires on top here, what happens is they react with oxygen gas and then produce water. So that's essentially how a fuel cell works. So basically, it converts hydrogen gas and oxygen gas into water, and that during the process of that, it produces electrical energy. And in terms of chemistry here, when the electron leaves the anode here, leaves this electrode here, we call this the anode. And when the electron combines with the proton and the oxygen atom in this electrode, we call this cathode, where reduction occurs. And the concept of oxidation and reduction is very easy actually, because so when electrons are lost, it is known as oxidation, and when electrons are gained, this is known as reduction. So effectively, the overall reaction is just hydrogen gas plus oxygen gas produces H2O, which is just water, and then you balance things out like this. So effectively, that's the reaction. Well, now we need to talk about the significance of the fuel cell. And well, one of the huge advantages of using a fuel cell here is the fact that there is no major loss in energy. For example, if you were to convert like the combustion of hydrogen gas and oxygen gas to produce electricity through like a combustion engine, it will only have about, I don't know, like about 20% efficiency, at most 20%, because first you need to combust hydrogen and oxygen gases, and then use that energy to boil water, and then use the steam that's been produced from the boiling of water to power the turbines, converting that into kinetic energy up the turbines, and then convert that through a magnet, and then converting that into electrical energy. So there's so many steps, but in fuel cell, there's only a limited number of steps. So a fuel cell can increase the efficiency of production of electricity to very high standards. So that's why a lot of research has gone into the field of fuel cells. And I hope you enjoyed this video. See you next time.